Thank you so much for making it today's session. So today's session will be the last session for this art training, and I'll be seeking to finalize on some elements of the data visualization which we did not complete last time. And if my colleague, the other facilitator, Ashna, happens to join, she will take it through an introduction of our statistics module that we had. So I'll just do a brief recap of what we did last time, of the kind of visualizations that we did last time. And let me share my screen. So last week we started on the introduction to the data visualization using R. So we described why we need to do the data visualization and why it's important, and why it's important to have an effective, visible, and well understood visualizations. Then we looked at the principles of effective data visualizations, which included clarity, accuracy, consistency, and relevance. Then we delved into how one can actually load the package, which brings together all the components of visualization, and that is the ggplot tool. And we said that if you happen to install tidyverse, tidyverse also comes pre-installed with the ggplot package. So we said that the building blocks of a ggplot includes the data that you want to plot, the aesthetics, the geometrics. We also had if you wanted to actually plot or have plots of visualizations in terms of columns and rows, we saw that you could use a building block which is called facets. There's also element of statistics, which included a binning that is for bar charts, and also smoothing for scatter plots. These others, like the descriptive and intermediate, those others are also covered in other kind of plots. We also discussed something to do with coordinates, though today's session I will be covering on how to actually use coordinates and themes in when you are actually doing visualization using ggplot. So some of the visualizations that we saw, there are scatter plots, there are bar plots, there are line plots, there are box plots, there are histograms, there are area plots. There's so many, and we saw that just by using the function which has geom underscore, then there's a suffix that follows it. This suffix now allows you to actually choose different kinds of plots. Okay, and we say that there are actually over 40 kinds of geoms that can be used to plot in ggplot. And for more details, I could actually follow this link, and it just give you a general idea as to how many plots are there. So we said that if you want to plot a histogram, you just use geom histogram, this function with a suffix histogram. Bar charts, you can use bar or col. For box plots, you can use a geom underscore box plot. For points, you can use geom point and etc. Okay. So for you to add a building block or a component in ggplot, we say that we just use the plus sign. Okay. So whereby you say that, and it's also possible to have one or multiple geoms added to the same graph just by using the plus sign. So we looked at how we could create a canvas. We looked at having a scatter plot from our HIV data set, how to do a box plot, how to do a histogram. You can also do a density plot by just calling geom density, and it does it for you. Then we also looked at how you could actually add aesthetics to the plots that you have, adding shape, feel, color, size of the points that you have, alpha for transparency, and opaqueness in those markers of the plots. Also the bin width to actually decide the width of the histogram bins, and etc. Width, line type, and we also saw a way that whereby you can either use the static value to declare the color that you want, or you can also assign a column of the data whereby the color will be dependent on the observation in that data. So that was achieved by either setting a static value, whereby you could actually explicitly say the color that you want. Like in this case, you can use red, you can use black, and etc. Or you could actually scale it to column values. By scaling to column values, you actually the color is actually decided by is dictated by how the data is. Like in this case, uh, if you said the color was equals to the HIV category, then it could just ensure that the the points or the geom point in this particular plot, actually the color is dictated by the HIV category. Then we saw that how you could also add smoothing. Smoothing. If you have a scatter plot, how can you how can you add a trend line in that plot? We saw also that, and increasing transparency by using alpha and etc. Okay. So today we'll just build on what we were doing last time. So we'll continue with adding the building blocks of a ggplot. So towards the end of last week's class, we saw how you could change themes, and I showed you the different kind of themes that you could actually use, so that you can actually make your visualization more appealing. So today we will start on axis code. I know I did this last time, but I think it will be a good point to start as well today. So we did axis coordinates, and axis coordinates we can say that you can use x lim or y lim, whereby inside these brackets, these parentheses, you dictate the limits of maybe the x-axis or the y-axis. Okay, but there's a caveat to that, in that this one does not always work. Okay, and it may lead to some data points being cut off. So what we can actually do uh, in ggplot is, you can see here, like in this chart here, sorry, in this code here, when you're using xlim, you can just declare that you want the lower value of the x-axis to start from 250, and the upper value to be 700. You can also add the limits that you want for the y-axis. Okay, that is 1,500 and 4,000. But you're saying that this may not always work, and it may lead to some of the data points being cut off. So instead of this, we can use this function, which is called code Cartesian, whereby now instead of declaring the limits here, we now declare the limits as arguments inside this code Cartesian function. We will see this in practice shortly. Like in this case, so you can see that now the x-lim and the y-lim, together with their limits, the vector showing the limits, have been added now inside the function. They've been added as arguments inside the function, the code Cartesian. Okay. Then we will also look at how there's last time we saw how we could add labels using the labs function, but there's also a better way that dictates the different elements of that label, and we can use it within the function which is called a theme, the theme function. Okay, just don't confuse it with the theme, which gives you basically the background color of that visualization. We will now use the theme function, where now we have control of what we want to do, be it the color of the labels, be it the size, be it the position, be it the type of the text, and etc. We can now have control, but this can only be done inside the theme function. Okay, we'll also see this shortly. Then after this, I think in some cases you may have seen when we were plotting, we were just plotting one visualization after the other. Okay, but you'll find that in practice, uh, there's actually need for you to do a comparison between different visualizations. So we will also look at how you can actually combine these ggplots and combining these ggplots, we can use the package which is called number one, which is called a cow plot. I don't know why, why it was called a cow plot. You can use a cow plot. We'll also use the packages called a grid extra and also the patchwork. So you can see like the diagram that we have here, you can see that I can have my first plot there and my second plot, which are actually plotted on the like on a horizontal row. Then below it, we can also stack another plot which is called plot three. We'll see, and this just allows you to actually combine several plots within a given chart. Okay, and this just makes it easier for you if you intend to do a comparative analysis or a comparative study. So it becomes easier to see the trends or uh, or the trajectory in a given two plots or even three or even just multiple plots for that sense. So we'll see how we can use patchwork. We'll see how we can use cowplot and also grid extra. Very powerful functions that also just improves on how or just improves on the outlook of the visualization. And the beauty about this, you can actually have uh, independent or independent options for each plot. You can have a different theme for each plot. You can have a different uh, axis or axis coordinates for each plot. As long as you do it for each separate plot, then what these packages will do, they'll just combine these plots together into one beautiful visualization. We'll see that shortly. Okay. So with that, now I think we can actually go to our visualization so that we can actually do it practically. So last time we stopped at themes here, whereby we looked at different themes. So let me just run this. We looked at different themes, whereby this one is the gray theme gray. You can also have theme black and white or theme light. So these are user dependent. You can always choose what you actually prefer for the themes. But to say that once you just uh, put a plus and type theme, it will actually suggest for you the different kinds of themes that you can use. Okay. So even before we proceed, you can see that in this plot here, the one which is active now, we use labs to declare the title, okay, to also label the x-axis, also label the y-axis, okay. But we'll see a different way of how we can actually achieve this. So we will continue with this scatter plot which we did, and it also had some trend lines. The trend lines or the color was dictated by the HIV gender. Okay, so now let us build on now on this and dictate. You can see now, if I zoom this plot, you can see that our data um, moves from 0 on the y-axis. On the viral load, that is the y-axis, we have the limit from 0 up to 5,000. And on our x-axis, it is from 0 up to maybe 1,000 or so. So we can actually have user-defined limits. So let me just copy paste this. Then if I paste it here, so now the theme was already declared. So we have and the size of the markers was and the transparency and all that was already done. Now we would like now to add the coordinate limit. So in this case, you can see if I just type the code, it suggests for me the code Cartesian. Okay, and in this case, I can just say lim equals to the vector defining. So in this case, I can say maybe I would like the x-axis to start from 250 up to maybe something just something like 700, just for argument's sake. Then I can also have the y-lim. I can also declare or define this as maybe I would like it to start from 1,500 up to 4,000, like that. Okay. So the theme, but now this I'm just having control of what limits my axis should be. So let us plot this and see what it gives us. So you can see in this case, the plot. So like for the x-axis now, the x-axis starts from 250 up to 700, 700. Okay. Then for the y-axis, we say that we would like this to start from 1,500. Yes, and it starts from 1,500, and it goes up to 4,000. Okay, so you can see there is a difference for us using the code Cartesian and the limits that we saw earlier. In that, what the other style does is that it just truncates and cuts off those data points. But for us, when you use the code Cartesian, it does it in a more aesthetic way. It just doesn't omit the data points. Okay, and as you can see, even if you have declared that the y-axis should be should start from 1,500, you can see there's still some data points which are below that. Okay. Then now we have declared or we have now user defined axis coordinates. Okay. Let us now also use the theme function, and this theme function we would like now to take control of of the of the nature of the labels, the title, the legend, and etc. Okay. So in this case, once you type axis, it will ask you what you want to do. So I can choose maybe axis. And you see, there are so many options for you to actually define or have uh, preferred options. So in this case, I will choose axis title, and that is X now. Okay. And what do I actually want to edit? In this case, I would like to edit the text. Okay. So if you type the word element, uh, I can go to element underscore text. Okay. And what do I want to do with this? I can say I want a color. I want to have my own color. I can say red. Okay. I can say red. Then I would also like inside that function element text, I would also like to dictate the size of that text. Maybe for argument's sake, let me say something like 25. The size I want it to be 25. Okay. Let us run this and we see what actually becomes of the x-axis. Okay. So you can see the label on the x-axis now has become size 25, and it's of a color red. Okay. So I may also want to also edit the y-axis. So it will be the same thing. The only thing which will change, let me just copy all of this from there. So the only thing which will change will be this part. So I can say this is y. Maybe my color, I would like maybe something like just blue. Just blue. And I can say this to be size 30. Okay. So if we run this, you'll also see that now the label, the y-axis label, that is the viral load, it is in blue in color, and the size is also larger. So I can also do other things, maybe something like that is the title. Maybe I want also to change these data labels on the axis. Let me also increase the size of them. So I can say, and there's so many there's so many options when it comes to the theme. So I can choose axis text on the x-axis. And what do I want to do? I want to access the element text, and I can change it to the size to be equals to maybe 20 or something like that. So while we're still there, I can also do for the y-axis dot y like that. Okay, then I say element. I want to edit the text. Okay, and inside this text again, you can always declare the color that you want. Maybe the text I want it to be maybe size 25. Just for argument's sake, if we run this, you see that the labels now, the data labels have also increased in size. You can see for the y-axis is larger because you have used 25, while for the x-axis you have just used 20. You can also say that you want to change the color, the color of this, maybe something like green. Let's see what happens to the x-axis if I say that I want the color to be green. Yes, it changes the color to green as well. Okay. So this you can add as many options as possible, and there are so many. So like I can also decide that the legend title, there is a legend title. Sorry, just a minute. The legend title, I would like to change it. Okay, and I want the text to increase the size of the text. So maybe I can say size equals to 20, or that will be too large, maybe 15. Then I can also decide the text of the legend. Let me also have a say on how that will look like. Okay, so I can also do that, and I can say let the size to be the same, maybe size 15. Maybe I can declare also the color there to be maybe I don't know. Okay, let me just say green so that you can see how it adds up. Then you can run, so you can see that the text of the legend has changed, and the size has also increased. What else can I do? I can also say maybe I want to change the legend position. The legend position. So the legend position, I can say, and this one you give it as a vector, because as a vector that will be defined by uh, x and y. So if you run this, you can see that now the legend is somewhat inside the graph. Okay, so this just shows you how powerful the theme function is, whereby you can actually dictate whatever happens in that visualization. You can have preference over anything. You can edit the labels. You can place the legend wherever you want. You can change the text of that legend, and 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 uh, and etc. Okay. Maybe also on top of this, I would like also now to add the title of the plot. Remember, the other one we were using labs, but in this case now um, I can just dictate what I want. Element text, and in this case I can say that I want the color, the color to be something like a dark blue, or maybe just Which color you can have? Maybe yellow. Okay, then we will see how that yellow will be. What size do I want this text to be? Maybe equals something like 20. Okay, and I can also choose the style. So the family in this case, uh, family equals to let's have something like Korea in that case. Okay. Then all these options are included inside the theme function. Okay, inside the theme function. Okay. Then finally, because I've declared some options for the title of the plot, I can use now gg title. Gg title now inside this I can say I want the name of this plot to be CD4 count uh, versus versus the viral load. Okay, versus the viral load, and that's it. So theme actually is a very powerful. It's a very powerful addition. Oh, yellow is not a good color. Let's have something like maybe just blue, so that we can be able to see what is being plotted. Yeah, that looks good, and you can see uh, it is of the family Korea. So you can have user-defined styles for the text inside that visualization. So themes, besides just using these labs here, themes also comes in handy when you would like to dictate how the plot or how the visualization will actually look like. Okay. I don't know whether there is any question up to that point. Okay, you can just put your questions in the chat so that I can complete also the other elements so that my colleague Ashna can do a bit that she wanted to cover. So in this case now, I would like now to combine the plots which I have. Let us pick some of the plots that we did last time. I can pick these three. There's the geom plot plus the jitter. There's a scatter plot, and there's also the histogram. These are three plots. Let me pick these three plots. I would like to actually combine these three plots. Okay. So by doing so, I can assign and call this plot one, the other one to be plot two, and the third plot to be uh, plot three. Oh, sorry. Sorry. And the third three uh, to be plot three. Yes, that's okay. Then now, using now the cow plot, please you will install the library cow plot because it's the one that contains this function that will help us combine these three plots. Okay. So how does cow plot help you to combine? So I can say let me just call this combined underscore plots like that. Okay. Then what do I actually want to do? I want to combine these three plots. Okay. So from the cow plot, I can call the function plot grid like that. Then which plots do I want to combine? I can have plot one. I can have plot two. Okay. And I can also have plot three like that. I want to combine these three. Okay. And I can assign labels to them. What labels can I give these three? Maybe I can have label. I can have maybe let me call it A. Let me also have B and C and maybe C like that because I have three plots, and I can also say Labels, 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 label, the tables. Okay. Then I can also say that I want the number of columns uh, to be 3. Okay. Just the plot grid now combines for you the 3 plots into a single visualization. That makes it easier for you. If you want to do a comparison, it will be easier for you to do it if the plot is just one. Okay. Then let's see. For me to view this, let me just say uh, print combined plot. So remember, you install the cow plot. You can use Pacman to install it, or you can just install it first, then come and unload it here. So if I run this, you can see that. Let me zoom this. Mm, Okay, sorry. Let me just clear first the plot history, then I can run this again. Okay, it's not possible uh, to zoom it at the moment, but you can actually see that I have 3 plots. That is plot 1, which is the box plot plus the jitter. Then there was one which was the scatter plot, and the third one was the histogram, and all of them have now been placed into just one visualization. Okay. Then that is one of the strategy that you can actually use to combine different different plots. Okay. Then I will also introduce the other one, which is called a patchwork. So you'll also library is called patchwork, that also allows you to actually combine the 3 plots. So we'll just combine again the 3, but in this case, let me just call this combined plots 2, so that we don't have it doesn't confuse the other one. And how do we use patchwork? Patchwork is even simpler, because you just need to know the plots which will be uh, horizontal and the ones which will be stacked below those ones. So you can have plot 1 there, then I can use that symbol, then plot 2 there. Then what do I want to stack below these two plots? I want to stack plot 3, like that. Okay. And I can just come and say again, print plots 2. Let's see what this gives us. Okay. It's just again another option for you to combine plots. So you can see for this one, what it has actually done, it has plotted plot 1 and 2 as a row in the first row, but whatever is stacked below these two is the plot 3. Okay, which was the histogram. That is how patchwork works. The other one was how the cow plot works. And finally, let us look at how the grid extra works. So we can also load. Remember, you need to install the packages. So you can also install the grid extra. Grid extra. We will also use the same plots. So let me call this uh, combined plots 3, so that it doesn't read from the other one. Plots 3, and this is easier because what you just need to do, you just say grid.arrange, and after that you just say what are you plotting and what number of columns do you need. So I can say I want to plot number 1, and I also want to combine plot 2, and I also want to combine plot plot 3. How many columns do I want? Let's say I just want just two two columns. Okay. Then I can as well say I would like to print, or I would like to visualize plot 3 here. Sorry, plot 3 here, like that. So if I run this, you will see that because you're the ones who have dictated the number of rows that we want, sorry, the number of columns that we want. So what it has done, it has just plotted plot 1, plot 2 as in the first row, then plot number 3 in the second row. So let's see if I choose this to be 3 columns, what will actually happen? If I do so, you can see that it has plotted them uh, according to the 3 columns that we had dictated. So these are some of the libraries you can use to combine the plots just for better uh, comparison. Okay. So I would like, in the interest of time, I would like to stop there. And if there are any questions, please post them on the chat. We also have the discussion tab. You can always post your questions there in R for Fun Club, and I'll be sure, and my colleagues and I will be sure to get back to you.